Welcome back, and with this video we are about to wind up our discussion about the ankle and foot complex. In previous videos we had a series on the biomechanics and pathomechanics of ankle joint musculature. Definitely the ankle complex itself is a confusing topic, and thus the musculature in ankle complex can also be a part of confusion. But here we will simplify it in the most easiest manner. And in ankle we have three pairs or three compartments of muscles: the posterior, anterior and lateral compartment. Of course, we had discussed about the posterior compartment in detail, and right now with this video we discuss the lateral and anterior compartment of an ankle complex in the most simplified manner. Yes, here we have two compartments as our topic of interest, that is the anterior and the lateral compartment. Let us first look into the lateral compartment, which is relatively so easy. Which are the muscles that are a part of the lateral compartment of the foot? They are the Peroneus Longus and Peroneus Brevis, or Fibularis Longus and Fibularis Brevis. Of course, the Peroneus Longus and Peroneus Brevis are known as Fibularis Longus or Fibularis Brevis, so they stand the same. So we have two muscles in this region, that is the Peroneus Longus and Peroneus Brevis, or Fibularis Longus and Fibularis Brevis. The same easy strategy of discussion. We go on to look where that muscle is lying with respect to the ankle joint, of course the talocrural joint and the subtalar joint, and we find out that they lie over here, Peroneus Longus and Peroneus Brevis. This red dots shows their position, relative position. Can you just look at that position and tell me what would be the function of these two muscles? Of course, just think on where are they lying with the ankle joint, anterior or posterior to the ankle joint. This is the axis of ankle joint. So where are they lying? They are lying posterior to the axis of ankle joint. So definitely the function would be plantar flexion, right? Very good. So the function would be the plantar flexion. Now, again the same scenario. If you are someone who is watching this ankle pathomechanics series for the first time, just go to the previous video. Then only you can understand this in an easy manner, right? Yeah, okay. And this is the axis of the subtalar joint. Where are they lying to the axis of the subtalar joint? They are lying lateral to the subtalar joint axis. So if they are lying posterior to the ankle joint axis, they are plantar flexors. So they are plantar flexors, right? Very good. If they are lying lateral to the subtalar joint axis, then they are known as the pronators. Right? So the function of Fibularis Longus and Fibularis Brevis, or Peroneus Longus and Peroneus Brevis, are they act as plantar flexors and pronators. More specifically, the evertors. They are more specifically evertors. This is the combined three-dimensional or multi-axis, multiplanar movement, but more specifically the single plane movement of eversion, because you know that this is the lateral side of the foot, this is the medial side of the foot, and if you imagine in this manner, this being the medial side and this being the lateral side, the muscles which are located in this side would help in eversion of the foot. This help in eversion of the foot or pronation of the foot. So more specifically, if you go on to identify the generalized function of Fibularis Longus and Fibularis Brevis, or the lateral compartment muscles, the muscles are plantar flexors and pronators, as well as evertors or evertors itself. But here you have to think on biomechanically. If you look at the ankle joint axis, which is the ankle joint axis? This is the ankle joint axis, right? They are so close to the ankle joint axis. So when the muscles are close to the ankle joint axis, definitely their momentum is going to be very less, and therefore they are weak plantar flexors. What are they? They are only weak plantar flexors. Of course, we have the posterior compartment muscles doing the function of plantar flexion. So these muscles being very weak plantar flexors. But of course, this is the subtalar joint. They are far from the subtalar joint relatively. I should draw this a bit more this manner, so that would be correct. So that is distant from the subtalar joint axis. Therefore, they are strong evertors. Eversion is a very crucial role, whereas plantar flexion is a minimal role. Right. is the origin of Peroneus Longus. The Peroneus Longus muscle originates from the tibia, lateral condyle of the tibia, definitely from the fibula and intermuscular septum or the introitious membrane between them, and it passes down, right? Whereas the Peroneus brevis passes from fibula and introitious membrane and passes down. Now, when these muscles are passing down, there is an important peculiarity for the Peroneus Longus muscle, which is our biomechanical interest. What is that? The Peroneus Longus muscle comes out like this. I'm unable to show the foot region. So imagine this being the lateral malleoli of the foot. Of course, you can feel it like that, right? So imagine this being the lateral malleoli. So the Peroneus Longus muscle arises from the lateral compartment and comes on like this. Then passes over the lateral compartment, lateral malleoli. So the first landmark over there, they passes over the lateral malleoli. And what it do is, it will go behind. It will go under the cuboid bone. Of course, you can see that in lateral side you have the cuboid bone, right? It passes under the cuboid bone. It passes under the transverse arch, the arch which is seen like this. That is your transverse arch. So it passes underneath the transverse arch, and which is this bone to be your navicular bone, lateral side, medial side, of course, and it inserts into the navicular bone over here, as well as to the first metatarsal, base of the first metatarsal. Am I clear? One second, let me try to help you with that one diagram. For example, if this is the lateral side, the Fibularis Longus tendon, it passes like this. Imagine this is behind, that's why I'm drawing the dotted line. It passes like this, and from here, when reaching the navicular bone, this tendon actually flips into two. One is going to be attached into the navicular bone, and second one will be attached to the base of the first metatarsal. So Fibularis Longus muscle is having such a great expansion, or such a great great difference in its orientation or in insertion, because this muscle is passing behind the ankle joint, behind the ankle or the foot complex, and behind the cuboid bone, behind the transverse arch. If this is the transverse arch like this, it is passing behind the transverse arch. It reaches the lateral bone, medial bone, that is a navicular bone, and inserts into the first metatarsal. So what is its functional significance? You know that when weight, if for example this is my first metatarsal, when I am inducing my weight bearing, or when I am progressing different stages of gait, ground reaction force can pull over like this and can provide the dorsiflexion of my first metatarsal. What happens if my first toe is going for dorsiflexion? My base support may get decreased. So what happens here is that your fibularis is attached to that from the down part. So it will cause the plantar flexion of the first metatarsal or first metatarsal. So first metatarsal, okay, or the first ray itself. So that is the functional significance of Peroneus Longus. What is that? The Peroneus Longus muscle arises from tibia, fibula, intermuscular septum or introitious membrane, passes down. When it reaches that ankle joint, it passes over the lateral malleoli, over the lateral malleoli, passes through the down of the cuboid bone and the transverse arch, and get inserts into the navicular and the metatarsal. So the first ray, what happens is that this muscle, due to its downward orientation, help in plantar flexing your first row when there is an excessive dorsiflexion moment as during the ground reaction force. So that is important. So that is a functional significance of Peroneus Longus. That is only done by your Peroneus Longus and not by your Peroneus brevis. Okay, that's only done by your Peroneus Longus and not your Peroneus brevis. So the Peroneus Longus muscle and the Peroneus brevis muscle are plantar flexors, are evertors or pronators. The plantar flexion moment is, or torque is very less, but the Peroneus Longus muscle help in the plantar flexion of the first row, So during gait, the Peroneus Longus muscle has a diverse role. It helps in transmission of weight from lateral side to the medial side. So if you have already studied your gait chapter, you can see that if this is the foot region, initially the weight bearing line shifts from lateral to medial side like this. The weight bearing line always shift or the center of pressure of the foot shifts. So that transition of weight from one part of the one part of the foot to another, from lateral to medial side, is facilitated by your Peroneus longus, because you can see that this is running in lateral to medial direction. So the Peroneus longus muscle helps in the facilitation of weight transfer during gait from lateral to medial side of the foot. Lateral to medial side of the foot. It also helps in plantar flexing the first toe, and hence maintaining the center of mass or the center of base of support, right? And also this muscle, you know that this muscle is crossing the transverse tarsal joint, subtarsal joint, subtalar joint, etc. So when there is a supination at the subtalar joint, for pronation twist to occur, this muscle also help. So the Peroneus longus biomechanically has various functions. One is that it is generally a plantar flexor, it is generally a pronator and everter, and it is also a plantar flexor of the first ray, plantar flexor of the first ray. It helps in the transmission of weight bearing line from medial lateral to medial compartment, medial side of the foot during weight transfer. It also helps in the pronation twist of the transverse metatarsal joint. It's clear? So when I stressed on the Peroneus longus, you can understand that that was a long discussion. So they might ask you for a 3 marks question. What is the functional significance of Peroneus longus muscle? What is the functional significance of Peroneus longus muscle? Or what are the role played by Peroneus longus muscle in the integrated function of the foot? And this is your answer, right? Okay. And since it's a biomechanics and pathomechanics discussion, pathomechanics of Peroneus longus and Brevis muscle weakness can provide what you call a restriction in eversion as well as the pronation. Definitely, you know that. So what happens is that when this eversion is being restricted, your inverters can become overactive, and they can keep foot in an inverted position or a varus position or an equinovarus position. So equinovarus or varus position of the foot may be attributed to the weakness of your Peroneus longus muscle. And more specifically, when there is a tightness of the Peroneus longus muscle, what happens is that earlier I told you, it helps in plantar flexion of the first metatarsal or first ray. So excessive plantar flexion will be there. So excessive plantar flexion will be there on the first metatarsal, and first metatarsal head may become or show some excessive callus formation. You know what is callus? It's some bony growth when there is an excessive weight bearing on that head. So you can see callus will be formed in the head of the first metatarsal, because excessive plantar flexion means this side of the foot will always press in the ground. So that is producing excessive callus formation, and thus it can precipitate callus formation in the first metatarsal. That's the Peroneus longus muscle. Peroneus brevis muscle weakness can reduce the balance between inversion and eversion. There is always a balance between inversion and eversion of the foot that may be reduced if there is an weakness of the Peroneus brevis muscle. Definitely, if there is a restriction, the range of motion can be the range of motion of inversion. The opposite movement will be restricted if this group of muscles are being tight. So that's the brief discussion about the lateral compartment. You just have to remember the Peroneus longus muscle is a very important muscle in this compartment. It is having large cross-section area and better torque generation capacity as compared to the Peroneus brevis muscle, and this muscle is crucial in the gait cycle or in the normal stance phase of the gait. So you have to remember about that. Let us look into the anterior compartment of the foot. Looking into the ankle-anterior region or anterior compartment, we of course have some familiar muscles like the tibialis anterior muscles, which we have over here, the extensor hallucis longus muscle, extensor digitorum longus, and Peroneus tertius muscle. So there are 4 pairs of muscles which are attached to the anterior aspect of the ankle complex, okay, or 4 muscles. What are they? The tibialis anterior muscle, the extensor hallucis longus muscle, extensor digitorum longus muscle, and Peroneus tertius muscle. Peroneus tertius muscle. Clear? Right. Now, when we look into this aspect, we see that these all muscles are passing anterior to the angle joint axis. Anterior to the angle joint axis. So, they are all dorsiflexors. So, all these muscles are very powerful dorsiflexors, or they are the chief dorsiflexors of your foot region, ankle and foot complex, because they are lying anterior to the angle joint axis. Now I want you to closely look. We know this is the axis of subtalar joint. This is the axis of subtalar joint. Can you just look at the difference between these four muscle groups in subtalar joint axis? The tibialis anterior is medial to the subtalar joint, whereas all of these are lateral or either in the subtalar joint axis. Therefore, the tibialis anterior muscle is any muscle which is passing medial to the subtalar joint axis are supinator. So the tibialis anterior muscle has that dual role or additional role of providing what is called dorsiflexion, then supination. Dorsiflexion and supination. So the second role of the tibialis anterior muscle is a role of supination. Clear? And now, if you look into the extensor hallucis longus, it is closely related to the axis of subtalar joint. And as a result, what can happen? They can provide some supination moment, but they are weak supinator. So the extensor hallucis longus muscle is a weak supinator. Whereas these two muscles, that is the extensor digitorum longus and Peroneus tertius muscles, are lateral to the subtalar joint. Therefore, they will be supinators. There are pronators. So you can see that even though these muscles are belonging to the same anterior compartment of the foot region, they have different function in angle joint and the subtalar joint. In angle joint, all of them are dorsiflexors. No doubt in that. In angle joint, all of them are dorsiflexors. Whereas in a subtalar joint, tibialis anterior is a very strong supinator. Extensor hallucis longus is a weak supinator, whereas extensor digitorum longus and Peroneus tertius muscles are what you call weak, evertors of the subtalar joint or pronators of the subtalar joint. So see the difference in function with respect to a single joint axis, right? Even though it is in anterior compartment, different functions are served by these muscles, right? Okay. And now if you look more clearly into the function of tibialis anterior muscle, you can see that this muscle is helping in regulating the plantar flexion, because you see this muscle is attached over here, so it will help in regulating the plantar flexion in the initial phases of gait. Because you know that when we are going for foot flat to heel strike, or what happens is that initial phases of the gait, heel strike phase, foot flat, mid stand phase. So during these different phases of gait, there is actually a rhythmic change or a synchronized change from what you call plantar flexion, dorsiflexion, plantar flexion, dorsiflexion. So that changes or that initial plantar flexion moments from the ground reaction pose or the initial plantar flexion torque, etc., are to be regulated. So there should be some regulatory mechanism. So during 0 to 10% of the gait, your tibialis anterior muscle is going to work as eccentric contraction, or it is going to regulate your plantar flexion. Whereas from 10% to different 10% to the next stages of the gait, your tibialis anterior muscle will regulate the pronation, because you know that it is supinator, so it will control the pronation. So there is a change in the function of tibialis muscle, and this is why I told you that we will take gait biomechanics after finishing the ankle complex, because it's not, why many of you find it difficult is because we are not much thorough with the ankle complex, because the function in the ankle complex is actually regulating the function in the gait complex, because gait is completely dependent on the foot and ankle complex. So understanding this biomechanics is important to understand that. So we saw now the tibialis anterior muscles at the initial stage, they control or regulate the plantar flexion, whereas in the next phase they will control the which movement? They will control the pronation. Because no need to worry, because this is a supinator, so it can control pronation, because it is going to be eccentrically contracting. Eccentric contraction of triceps can regulate Which movement? The elbow flexion movement. Extended contraction of a biceps can regulate the elbow extension. The opposite movement will be regulated. I think you know about that. So that is about the tibialis anterior muscle. And about the extensor hallucis muscle, we also has its significance in gait. That is, it is more active in the initial phase. It will help in regulating that initial plantar flexion moment. So there is an increased initial plantar flexion moment during the weight acceptance phase, etc. So during that moment stage of initial stages, this extensor hallucis longus muscle help in regulating the excessive plantar flexion moment. So that is the function of this one. So whereas tibialis anterior is regulating plantar flexion, and at the same time in the second phase of the gait or in the next phase of the gait cycle, it moves to regulate the pronation. That is more clearly, it is from 0 to 10 degree, it is regulating plantar flexion. 10 to foot flat, it is regulating the pronation. 10 to foot flat, it is going to regulate the pronation. Whereas you come to extensor hallucis muscle, it is active in initial heel strike phase to regulate or dampen the greater impact of plantar flexion moment. That is the role of your two muscles, tibialis anterior and extensor hallucis in gait cycle. For example, now if you think back to the previous video and this video, we are specifying more into the gait cycle when we are discussing about the ankle complex, and that is the importance of ankle biomechanics. In ankle complex, pathomechanics and biomechanics of foot musculature, it has a crucial role in gait cycle. So you have to remember about that. There is no other way. You have to remember. But it will become easy when we look into the gait complex biomechanics. And finally, let me add on to some other functions of extensor digitorum longus and Peroneus tertius muscle or Fibularis tertius muscle. You know that it is extensor digitorum longus. I told you they are pronators and dorsiflexors. At the same time, digitorum, they are going for the digits. So it will help in the MTP extension. It will help in the MTP extensor. Hallucis also help in the extension of big toe. So these muscles also can help in the extension of the big toe as well as the other toes. So that is the function of which muscle? That is the extensor digitorum longus, and an additional function, they help in the extension of a MTP joint. Now, if there is a tight weakness of tibialis anterior muscle, this is the strongest dorsiflexor. This is the strongest dorsiflexor. So if there is a weakness of tibialis anterior muscle, what can happen? What can happen? Dorsiflexion may be limited on. So people will walk with the foot making some flapping sound, a foot flap sound on the ground. Whereas if there is a weakness of all of this muscle or 2 or 3 of this muscle, there can be foot drop. That means excessive plantar flexion. The plantar flexors would go for the excessive action because there is no regulatory mechanism. So the people will have the foot drop. You know what is foot drop? I think so. You know, even if not, we will discuss in the post chapter what is foot drop, etc. So it will precipitate in foot drop. Whereas the tightness of extensor hallucis muscle will restrict the motion of the MTP, etc. But at the same time, its weakness can produce a deformity known as clot or deformity. The weakness of extensor hallucis longus can lead to deformity known as the clot or deformity. And at the same time, all of these muscles, for example, if they are tight, definitely the plantar flexion will be limited. If they are loose or weak, definitely the dorsiflexion will be limited or dorsiflexion may be absent. And definitely extensor digitorum, if it is tight, it can decrease the range of motion available at the MTP joint. If it is weak, MTP extension would be limited. So that is how you have to understand the pathomechanics and biomechanics of the muscle. If the muscle is tight, it will restrict the opposite movement. If the muscle is weak, it will definitely reduce the strength of the same movement or the movement that is produced by that muscle. Right, so it's time to wind up this session of the ankle complex biomechanics. I think that we have about 16 or 17 videos, and this is the complex with a large number of videos. So usually we have 13 or 14, and this is 17 videos, right? And it's a big task. And ankle is always a complication. I think that you are pretty well thorough about the ankle complex. Okay, and what we'll do is that, as many students requested, or just for the students, we'll discuss one day in another video which are the most important things to study in ankle for the examination point of view, because studying all this can be a cumbersome task. And with this, I wind up this video. And if you like the video, click the like button and subscribe to our channel, and don't forget to share with your friends so that we can reach more and more number of students and help them in learning biomechanics.